Hi there, so I wanted to share this little device I created, just because I thought it was cool. This is essentially a nuclear battery, which is a device that creates energy from radioactive decay. I thought to share this because not only is it kind of cool, it's also really simple actually, and it shows that nuclear technology does not have to be scary. This isn't scary. So, at the heart of this is a tube of tritium, which is hydrogen 3. It's hydrogen with 2 neutrons instead of no neutrons and 1 proton, of course. It decays by beta emission, which means the nucleus shoots off a high-speed electron. In this case, the energy is about 6 megaelectronvolts. And it also shoots off a neutrino, but if you've studied any physics, you know that neutrinos can't really be used. But you can use the electrons. So, what you can buy online, perfectly legal, are tritium tubes. They're about this size, although they do vary. These are also used in exit signs that glow without electricity. Anyway, you buy one of these tubes. It's just a glass tube full of tritium. That's basically it. The tritium decays with a half-life of 12 years, so after 12 years, half of the tritium will have decayed away. Decays into helium-3, which is actually a pretty rare helium isotope, but there's not enough of it to matter in these tubes. The inside of the tube is coated with a phosphor, which, when the beta particles hit it, glows green. So that's the whole point of these. They sell them as keychains or, again, exit signs. You hold it in the dark, it glows green. It glows, well, until everything decays, which is a very long time, but you're not going to see the glow much after 20 years. But for 20 years, you're going to have a light that just runs forever. Now, it's not very bright, but I saw this and thought, well, surely you can get some energy out of this. Now, it's hard to find out how much tritium is in it, but I found a much larger tube that glowed, and they had listed how much tritium was in it. You measure it in how much decays per second. And I assumed the density was constant and found out that in this volume, about this size, you're going to have about 3 times 10 to the 9th decays per second. So every second, that many atoms are decaying and releasing electrons. Now, before anyone complains about radiation, it's not dangerous. These electrons are incredibly low energy for beta particles. They're very low compared to something like strontium-90, which actually could be dangerous. There's no breaking radiation. I can't say the German word, so I'm not even going to try. And you won't get hurt by this. The beta particles are stopped by about 6 millimeters of air, and anything else is just going to instantly stop it. Aluminum foil. Here's the fact: they don't get past the tube. It's perfectly safe. People wear this around their neck oftentimes, and it's legal. Anyway, it's glowing. I figured we can get some energy from it. Now, if you use that 3 times 10 to the 9th, you find out that the maximum energy is around 3 microwatts, if I remember correctly. That's very, very, very small, but you have to remember, you're not going to get 100% efficiency. So I decided to take a solar panel, like this, and strap it against the tube, and then put some aluminum foil around it. Sorry for my horrible diagram. Anyway, then, you put it in the dark, and theoretically you should get some energy. Now, I originally tried this with a pretty large panel, and it really didn't work. I got 1 millivolt, which is useless. Completely useless. But I eventually thought, well, calculators have smaller solar panels, perhaps that would work. And sure enough, bought a $3 calculator, pulled the solar panel out, and I am actually producing usable electricity. Now, it's incredibly small, so small that it's hard to measure the current, and the multimeter actually has trouble reading the voltage in the first place. But I put a reflector on, that about doubled it, almost. And yeah, you actually get usable power from this thing, from just the light from the radioactive decay. It's enough to light an LED for about a second if you charge it for a couple hours. So, again, it's not useful. This is really a novelty. But yeah, it's, again, it's technically nuclear technology, and it's not dangerous. It's incredibly simple. It's, again, not dangerous at all. And I have this multimeter, so I'd like to show you the voltage here. We have... That's going to be volts. We take these, put it against the terminals. That's 1. That's 2. Now you notice it says 0.49. It's actually not the voltage. If I charge a capacitor up, which is what I've been using for energy storage, it actually is about 1.5, 1.6 volts. And I believe the reason for that is because of the current being so low that the multimeter actually has trouble reading it. Now, when I was able to measure, the power is somewhere between 50 and 100 nanowatts, which is incredibly low. And you have to charge these capacitors for a while and then use it with a voltage boosting circuit I got from a garden light in order to even light an LED. But it does work, and it does produce power. And yeah, I've not really seen a working one online yet, so I thought I'd just share this, and that's it. Thanks.